Here we're going to use Stapplet, a very powerful applet set, to calculate values from normal probabilities. Those values could be an X value, a Z-score, a mean, or a standard deviation. So, by the way, if you're calculating mean or standard deviation, I'll get to that part in just a sec. So first of all, you're going to pick normal distributions here. All right, so normal distributions, it's on the top. So you see this once you go to stapplet.com. All right. Then instead of doing calculating an area, make sure the drop down says calculate a value. So this drop down, make sure it says that. And enter the mean and this, which is 0 if you're doing Z-scores, all right? But if you do know the mean, you can just put it straight in there, okay? It does default to the mean and standard deviation for Z-scores. Then you enter the standard deviation, and again, if you don't know the standard deviation, go ahead and use the Z-scores. The standard deviation for Z-scores is 1. Then you have to determine if you want left tail, right tail, or central. Left tail is for the problems of the form x is less than a number. Right tail is x is greater than a number, and central is x is between two bounds, all right? And all of these are going to be equal to the area. Then you're going to enter the area in decimal form, and that should be in a value somewhere from 0 to 1. Press calculate values, and then they'll be displayed to the right. Now, if you did not know the mean or the standard deviation, and that's what you're trying to find, the values you get will be Z-scores. Then you can actually calculate your unknown value that you're trying to find using the formula value minus the mean divided by standard deviation equals Z-score. So you know the Z-score from the applet, and then you know 2 of these 3 values, and then it's a matter of doing some algebra to solve it. So we'll do a quick run through. All right, so this is how you can use the normal distribution Stapplet to determine a value corresponding to an area. So if I revisit, say, the tomato box filler problem in our notes, we had a mean of 80 ounces and a standard deviation of 4 ounces. And you hit plot distribution, and you can see it, and there it is. So you can see the values for the empirical rule right there. And I want to say the lightest 5% of boxes. So is that on the left or the right? Well, I know the area is 0.05, all right? If I hit calculate value, that shows that that would be the lightest. If it was the heaviest, it would be over here. These are the heavier boxes. See how you're 88, 92, and more ounces? But we want the lighter boxes. So I just hit the calculate value, and voila, there's my value right there. Also, you can use Z-scores, especially if you do not know the mean or standard deviation. And you can say, oh, what's left of 1 standard deviation? So, whoops, the left tail area of 1, oops, why isn't it doing that? Oh, that's, I did 100% area. So if, let's say I want to cut off the lowest 25%, hit calculate value, and there you go. All right. Yeah, because I'm not putting in values here. I said 1 standard deviation. I'm putting in areas. So if you put in 1, 1 is the maximum area, right? And 0 is the minimum area. If I want the lowest 10%, I could do that. If I want the highest 10%, I could do that. If I want the middle 10%, I hit central. And that's it. And it'll tell me, because I have 0s and 1s in here, it'll give me standard deviations. If I put in the actual values in there, it will give me the actual range in ounces.